Welcome to Learn Yourself. Today we are going to learn and understand about atmospheric refraction. Under this atmospheric refraction, we are going to discuss various topics like position of the stars, twinkling of the stars, why planets do not twinkle, and many more important concepts. So let us start with our first topic, that is position of the stars. It says that position of the stars, what we are seeing, is actually above than the actual position of the stars. So we will be able to see a stars little bit above compared to its actual position. Why this will happen? So starlight entering into the Earth's atmosphere, and after that it will get continuously refracted because of the Earth's atmosphere. And we know that there are many layers of Earth's atmosphere, and each and every layer there will be a changing of the air, and there will be a denser, cooler, hotter air will be there. One simple phenomena if we will understand, then when water is boiling. For example, this is a vessel and water is boiling, so whatever vapor is going up, if you will see in this region, then we will not be able to see this region clearly, and we will see that this region is flickering or it is wavering. Now why that is happening? Because whatever air present over here, that air is hot air, and hot air's refractive index is little bit less compared to cool air, because hot air is less denser compared to cool air. So here refractive index is less, whereas outside this region where hot air is not present, their refractive index is more. So you will see little bit different pattern or the wavering phenomena over here where the hot air is present. Similar, this kind of effect will be able to see when we are looking at the stars, because starlight is passing from all the different layers of the atmosphere. What will happen when starlight is entering into Earth's atmosphere? The starlight is coming and passing from Earth atmosphere, where Earth atmosphere is denser compared to the space vacuum, because their air is not there. So our Earth atmosphere is denser compared to from where the starlight is coming. So it is coming from rarer medium to denser medium, so it will move towards the normal. It will move towards the normal as it will enter into the Earth atmosphere. So as a result, if the star is here, we will be able to see the star little bit above. And if the person is standing here, then actual position of the star is here, but we'll be able to see here because the starlight is bending towards the normal. It is coming towards the normal. So that's why the apparent position of the star will be little bit above compared to the actual position. So starlight bend towards the normal as it enters into the Earth atmosphere. Star appears little higher or above compared to its actual position. And position of the stars are not stationary. Why? Because since Earth atmosphere physical conditions are not stationary. We know that Earth atmosphere is the thing which is continuously changing. And this refractive index is depending upon Earth atmosphere. As this Earth atmosphere is not stationary, this refractive index is keep on changing. So that's why the position of the stars will not be stationary. It is depending upon how much this ray will bend and how much it will come towards the normal. Accordingly, we will be able to see the star's position. So it is fluctuating and it is not stationary. Our second phenomena is twinkling of the stars. We know that stars are distant objects. They are very far from us. So for us, stars are a point size source of the lights. So when this point size source of the lights, these light beams are entering into the Earth atmosphere, it will pass from layers and layers of Earth atmospheric region. And we know that Earth atmosphere is not stationary, it is continuously changing. So because of that, it passes from all the different region, and so that it will show us this kind of flickering effect. This flickering effect is same as we have discussed earlier, that when any water is boiling in the pan and these vapors are going up. So in this region we'll be able to see that flickering effect, that wavering effect when where there is a hot air is there, because hot air's refractive index is different compared to cool air. So here we'll be able to see the flickering effect because this region is different from the other region. Similarly, when starlight, which is a light beam which is passing from a earth atmosphere, it will also show a similar kind of phenomena because it is passing from a various region which has a various diffractive index. So it will show a flickering effect, and because of that sometimes stars we look at, they look brighter, sometimes they look fainter, and this will give a twinkling effect to stars. So stars are very distant, they approximate point-sized sources of light. As the path rays of the light coming from the stars goes on varying slightly, an amount of starlight entering the eye flickers, because this starlight is also varying as it passes from different refractive indexes, and the amount of starlight entering the eye, it will flickers. And that's why stars sometimes appear brighter, sometimes fainter, and this will give twinkling effect to the stars. Our third point is, why don't planets twinkle? So planets are much closer to the earth, and they are extended sources and large number of point-sized sources of the light. Here many sources are there, and whereas into the star it was only a point-sized source of the light. Here there are large number of point-sized sources of the light. So from each and every point, number of rays are coming towards the earth. So total amount of light entering our eye from all the individual point-sized sources will average out to 0, and thereby nullifying the twinkling effect. So many rays are falling on our light and it will nullify twinkling effect, and that's why planets do not twinkle, whereas the stars are only point-sized source, whereas they are very far from us, and as they are entering into the earth atmosphere they will flicker, and they are passing from many regions of the earth atmosphere. They will flicker, and because of that will be able to see them twinkling, whereas planets are rays which are coming from each and individual point-sized source. When they are falling on our eye, that average, it will average out to be 0, and that's why it will nullify the flickering effect and twinkling effect, and that's why planets do not twinkle. Our another point in atmospheric refraction is advanced sunrise and delayed sunset. As per this phenomena, it says that we will be able to see 2 minutes after the sunset. That means if this is the horizon, then if the sun has go past the horizon, after that also past 2 minutes we'll be able to see the sun even though it is down the horizon. And advanced sunrise means we'll be able to see the sun even if it is down below the horizon, and then also 2 minutes before we'll be able to see the sunrise. So as per this phenomena, we'll be able to see the sun 2 minutes before and 2 minutes after the sunset, even though the sun is just down below the horizon, and actually we shouldn't be able to see the sun, but then also due to atmospheric refraction we'll be able to see 2 minutes later and 2 minutes before the sun. So the sun is visible to us 2 minutes before actual sunrise and about 2 minutes after actual sunset. This happens due to atmospheric refraction. Now let us know the reason that why it will happen. We know that sun is very far from us and from earth. So when sun rays, those light rays are entering into the earth atmosphere, they are entering from vacuum, that is a rarer medium, to a denser medium, that is earth, atmospheric medium. So from rarer medium to denser medium, when light will enter, it will move towards the normal. So if light is entering like this, then this is a rarer medium and this is a denser medium, then it will move towards the normal. So here, if we are considering this horizontal line as horizon, then this light ray will come like this, and we will be able to see after sunset and before sunrise. After sunset and before sunrise, sun is just down below the horizon. Even though we'll be able to see, and this is the apparent position. Apparent position means where we can see that. So this is apparent position and this is actual position. So once the light ray is entering into the earth atmosphere, let us imagine that this is earth atmosphere, which is a denser medium, and this is vacuum, which is a rarer medium. So from where the rarer to denser it is entering, it will just move towards the normal. And this is why we will be able to see 2 minutes before and 2 minutes after the sunset. At both the time, after sunset and before sunrise, sun will be here only, down below the horizontal line or down below the horizon. So that is its actual position. But due to this atmospheric refraction phenomena, we will be able to see it here. That is apparent position, and we will be able to see here after and before sunset and sunrise respectively. So light enters from rarer medium to denser medium. So light rays will refract and bend towards the normal. This reason will remain same for both of this thing, that sunrise and sunset, because in both the situation the sun will remain here and the light rays will bend towards the normal, and we will be able to see the apparent position over here. So hope this video has cleared your doubt. In coming segment, we are going to discuss many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.